I'm Mark Stokes. I've been with SAFE a little while. I'm on the FME experts team here, and yep, today we're walking through training on advanced attribute and list handling. My camera's on one side of my two monitors, and I'm going to be looking at the other side. So if it doesn't feel like I'm looking at you, sorry about that. It is a little bit of an odd setup. Okay, so we've got a couple of hours. We're going to walk through some ideas on different attribute handling and a little bit of focus on list handling with FME. Hopefully most of you are already familiar with FME. If you're not, just follow along, and if you are, then you can do some of the little exercises we've got for you today. So the course is going to be a mixture of the slides that I've got here presenting. If you're if you're watching the presenter toggle that Ryan was mentioning there, and then we've got a few Knowledge Center tutorials that Ryan gave you the link for that we'll kind of follow loosely. I have downloaded and put all the sample data that we're going to need this morning or this afternoon, depending on where you are, and the workspaces, and they are all in this folder here. So go and have a look at that. That's not a good sign. Oh, there's my lab, and so that's this folder here that you'll see. See local FME data 2020 resources advanced attributes, and you'll see all the workspaces there, the source data, and if you want to write out data, then that will end up in the result data folder. Okay, so where we're going to start today is looking at a couple of ways that you can access attributes in a different way in FME. And one of them is called adjacent feature attributes, and the other one, which you don't see or don't use very often, but you see all through FME. So we just sort of thought that we'd just show you where that can be used. It's a fairly esoteric kind of piece of functionality, which we call the current attribute. So adjacent feature attributes. So that's a tool that's available in Attribute Manager, Attribute Creator, that allows you to look at the attributes from the previous feature that passed through the Attribute Manager, or actually will also let you look at the subsequent feature as well. So it looks sort of like a look ahead or a look behind function. So a couple of examples in there are moving averages. So if you want to build a moving average of your data, then you need to average the data of several rows, and so this is a good way of doing that. It's another useful thing for sort of aggregating by row. If you don't have IDs, if your data is very sequential, you can do that. So we've got a couple of very simple examples that we can look at. So I'm going to go to my lab, and I'm going to bring up the exercise 1A current attribute example. So you can have a quick look at that, open it up as well if you want. So I'm in the FME Data 2020 Resources Advanced Attributes folder, and I'm just going to open up this workspace here. Well, actually, it's already open here. So a very simple data set, and this is a data set that we're going to be using quite a bit throughout the day. And I got to run the thing first. It's our cell signals, so it's just some cell signal data that we've got from our training data. Let me make this a little bit bigger. And as Ryan said, these FME Workbench runs a little slow when you first fire up your Strigo, so if it is waiting a little bit, then don't worry too much. That's just your virtual machine waking up for the morning. Okay, so that's our CSV data that we're going to use quite a bit this morning. Just some simple point data with power and quality of some cell signals, number of measurements, a couple of other things, and a timestamp that we can work with later on. Here's the data as it is, and if I go and select a row, it should give me the feature information down there in my visual preview. Okay, so I've got a attribute creator here in this workspace already set up, and you can have a look at that. And this is an example of using attributes. You can find the advanced attribute handling tab in attribute creator. So normally that is closed because it is an advanced functionality, so we don't show it to everybody when they first come into attribute creator or attribute manager. And you can pop that open, and there will be a second panel here called enable adjacent feature attributes, and you can check that on. And this will be the number of features you want to see in front of this current record, and this number here, the subsequent features, is the number of features you want to see after this current record. So in fact, within this attribute creator right now, we're going to be looking at 5 different records from that CSV file, the 2 in front, the current one, and the 2 behind. And then how do you access these things? Well, when you look at an attribute list, once you've checked off that adjacent feature attributes, when you pull up an attribute list, what you'll see is the current attributes, which are attributes that are sort of shown in the way that you expect. Here's the code, lat long, power, and quality. And then you'll see another set of attributes with, in square brackets, minus, and we've also got in square brackets plus, and that's +1 or 2, -1 or 2. So those are the 2 features in front and behind. And then you can pick any of those attributes that you want to work with in the normal way. And so in here, what we're doing is we're building a moving average, and I'm just going to pop that open. So I'm using some of the math functions here, I think it is. Yep, that's the average there. And then I can go into the FME feature attributes and select the list of ones that I want to work with, which in this case are the power attributes. So I've got a list of values there in my average function, and it's going to give me the moving average. I'm running this with feature caching turned on, and so we should be able to see the results pop up there. And that's the results we have there for the moving average down in the feature information window. So if you've got any questions around that adjacent feature attributes, let us know, and we'll try and answer them. There is an article that is related to this, and Ryan's also sharing out the slides there, so that you can work with these slides later on if you want to work through this material again. Okay, we've got another little example of where somebody might use this adjacent feature handling thing. It's a little bit more, this is a real-world example from one of our customers. And it shows that you can sort of solve odd problems here. So that's example 1B, if you want to have a look at it. If you do get the workspace may not be compatible come up, that's just because built this in a very slightly different version of the FME 2020 release, so you don't need to worry about that, and you can just click OK. Okay, I'm not pointing at the right folder there, so let's try that again. So if you run that, just point at the right folder. That's a test for us to make sure that we know how to grab the correct file. So agg4.txt. Okay, so I have actually no idea what this data represented. It came in to us when we were talking to one of our customers. And so the requirement was here is that if the value of t is less than or equal to 3, this column here, the t column, then what they want to do is they want to sum the values of n together. So I've color-coded these to kind of illustrate how that would work. So we've got the first row is 50, and then because t is less than 3 here, what they wanted to do was now sum the values of n for all of those t values where they're less than 3. And so the data sort of gets grouped together a little bit. So this would be actually fairly tricky to do. There's no IDs that link the data together. The data is just purely sequential. This is fairly common of other kind of data that people encounter, particularly people working with linear referencing systems often get spreadsheets of assets where they want to build the begin-end markers for assets or pieces of pipe or something like that. And so we want to try and do that calculation. So how do we go about that? All right, so in our attribute manager here, what we can do is we can build a conditional value. Well, what I'm doing here first is just creating a test to see whether the value of t is less than what I need. And if it is, then what we're going to do is we're going to get the value of the previous value of L. Okay, and so what we're doing here is essentially we're grouping all our data, creating a temporary ID to all intents and purposes in this attribute manager for the value of L. And so we basically build ourselves a key based on the value of t. If t is less than 3, then we use the previous value of L. Let me go back to that again. I didn't explain that very well, I don't think. So if the value of t is less than 3, then we use the value of the previous L here. And so we keep on accumulating that value of L. So L, in the previous case, the L was just numbered sequentially, but now any value of t that's less than 3 will get that first value. And then in the statistics calculator, we can use that temporary key as the way to group our statistics and come up with the sum of those values. So you can see here we can solve some fairly tricky sequential kind of problems where the data is not really related to each other except by the sequence, and there's the results there of our output. We've reduced the number of rows that we're working with by the statistics calculator. So if you have data that is very sequential. There's no relationship between the rows except their position in the data, then the adjacent feature handling tool is definitely something worth having a look at and trying to work with and see if that solves your problem. And of course, that kind of data is usually coming from Excel or CSV kind of data sets that we work with. Okay, I'm going to go back to the first example, example 1A, just to show you this current attribute function that we have in FME, which you see all the time, but is only useful in a very limited number of places. I'm just going to run the workspace. What's that workspace doing? Stalled. Oh, there we go. So whenever you're in any of the attribute handling transformers in FME, what you typically see is somewhere where you can select attributes. So over here in the attribute creator, we can select attributes from usually a list here, depends where you are. We can select an attribute value, that's fine there. Or sometimes it'll pop up into the text editor, or you can explicitly select the text or arithmetic editor. And what you'll see at the very bottom of the list of attributes, we've got all the feature ahead and feature behind attributes in there. You'll see this guy here, the feature current attribute. And so that is a kind of a function that just tells us what is the current attribute. And there's a couple of ways that you can use that. And the places that that is most useful, and if anybody else is in the group has used this before, be very curious to see how you've used it. So feel free to pipe up there in the chat. So an example of using that is in the expression evaluator. So the expression evaluator allows us to run an expression on one or more attributes. And so if we know we're going to use the same function or same operation on several attributes, then the expression evaluator allows us to do that. So in this case here, okay, so yeah, so this is an exactly kind of example that Joanna suggested here, converting lengths from feet to meters. And so in this case here, I've got power and quality attributes, and I just want to round them all up to a value of 1. And so instead of having a separate function for both power and quality in something like the attribute creator, what I can do is I can select those two attributes here, and then I can use the current attribute function. And so how you would do that is you would just go and choose the function that you want to work with. So in my case here, it was a math operator, the round, not a math operator, math function, sorry. Double click on that, and then instead of selecting a specific attribute here, I can select the current attribute, and in this case I selected the precision. And so what that will do is the current attribute function will cycle through whatever attributes you've selected up in here, the attributes to overwrite, and that's what the calculation will be done on. So that's something that you won't use that often, but is kind of in your face all the time. And so just thought we'd kind of clarify if you have been curious about how you might use that current attribute function that's sitting there in the expression evaluator all the time, there's a little example of how you might use that. Okay, any questions so far? So adjacent features, the most useful there, and then using the current attribute in a few kind of specialty spots there. All right, just moving along. A couple of articles around that if you want to have a look at that. Actually, those, I think Ryan's posted those up in there. That Time Machines and Attribute Alchemy was a webinar that we did quite some time ago that covers some of these ideas, and Validate Your Data Attributes is another webinar that covers some of these thoughts. Okay, so that's a little diversion from our main task for today. We're going to be looking at regular expressions. I'm not going to give you a course on regular expressions. There's tons of material, tutorials available on regular expressions that you can work through. So if you feel from this little tutorial that we're going to work through here that you want to get involved in regular expressions, then yep, go off and have a look at a couple of those tutorials. So what are regular expressions good for? Why would you want to get involved in these gnarly little scripts? Well, they're really, really useful if you have to do a lot of work with strings. They're great if you want to test for patterns or conditionals within strings. So here's a bit of pseudocode. So if you have a string and it contains a substring, then do something. So here's an example, which we're going to be kind of using a little bit, comes from our cell signal data. If I've got a station ID and I want to validate that to make sure that the first three characters of that code, that station code, is either A, B, or C, and then it's valid, that would be a really good place to use regular expressions. You can also use them for more complex search and replace within attribute values or strings. So you can replace parts of substrings in expressions. You can extract part of a string from, or a substring from, a longer string or attribute value. So that's where these are good for. And as above there, you can do some good attribute validation using regular expressions. So as I mentioned, this isn't a course in regular expressions, but hopefully a little tutorial that illustrates why you might want to use them and get involved with them. And so here's some examples of some more complex problems that people, customers have solved with regular expressions. So obviously they look very intimidating, and these ones are. Deliberately picked some nasty ones here. So in this case here, the customer wanted to pull out the sheet number from the strings he had. And so, you know, these sheet numbers had a fairly distinct pattern. Starts with a character, has 3 numerics after it. But it could appear, obviously, seems like in any part of the string. And so this gnarly regular expression allows them to pull that particular pattern out of this very descriptive text, and then they can use, they know what map sheet or whatever they're working with. And here we have an address validation that somebody wanted, so the address has to sort of fit a fairly standard pattern. So ouch, that if you're not familiar with regular expressions, that might look pretty intimidating. There's a great tools, again, available online for working with regular expressions and experimenting with them and learning how to use them. And the one I use a lot is regexpression.com. So you can have a look at that if you want to see how that's whether that helps you. Okay. All right. So I mean, we often need to do work with strings, and if you find regular expressions intimidating, you don't actually have to use them within FME. So we have lots of tools and functions within FME for working with strings where you don't have to get involved in regular expressions. So although I'd encourage you to start working with them if you feel like you want to spend the time learning them, if you have a particular problem that you need to solve, don't feel that you have to use them in all cases. So there's lots of functions. So in the text editor in FME, you're going to find under the string functions loads of different functions for working with strings, substrings. So this is my string name, and then I want the first, from the first character to the third character, I want to extract that. So you can use that function instead of using a regular expression, turning things to uppercase, trimming strings, replacing parts of strings, and so on. So lots of functions in FME for doing that kind of work without digging into regular expressions. And most of these functions have an equivalent transformer as well. So there's a string trimmer, string padder, case changer, I think, is in the bulk attribute transformer. So that's a bundle. Some of these are bundled together in a single transformer. So you can work with them either in the text editor directly or as individual transformers. So if you're finding regular expressions a little intimidating to get started with, just remember there is probably a function or transformer that will allow you to do some simple string manipulations. But if you want to dig in, some of these functions, as well as available in transformers, regular expressions available as functions as well. So replace regex is a regular expression function that you can use right within the text editor instead of one of the transformers. Okay, so if you feel like you want to get into the regular expressions, then first thing to remember is that most regex problems have already been solved by someone. So if you have if you have a problem that you need to solve, start searching the internet, because that's most likely somebody has already solved the problem for you. Here's a very esoteric example that I've got. Someone in Belgium has evaluated all kinds of different regular expressions that can validate a URL. Take a little while to come up. So this guy has looked at a whole bunch of different people that have published different regular expressions for validating a URL, and he's assessed them all. Down at the bottom, it's working a little slowly. Down at the bottom, he lists the actual regular expressions that these people have used. So if you want to check these out, you can. And so they're all scored against different URLs that he's got down the side here. And the pink is not giving such a good result, or a false positive. So that's, and I think it was a couple over to the right here. So again, just illustrates that, you know, if you needed to validate a URL, somebody has already done all that complicated work for you. In this case, you just got to choose the one that seems to fit your needs the most. So, yep, if you think you've got a problem, string problem that you want to solve, somebody has probably already solved it on the internet, and all you need to do is search, and you will probably find that pattern. One of the tools of one of those many tools that allow you to assess regular expressions is regexer.com. Sorry, I'm flicking backwards and forwards a bit. I'm going to go back to my lab. And so this is a great tool for understanding regular expressions as you build them up. So you put in the little bit of text that you want to work with here, and then you can start typing your regular expression. And what I really like about this particular tool is that it explicitly tells you what's going on. So when you click on a part of the regular expression, so it's highlighting here the capture group, and so there it's showing down here in green that this is capturing group 1, captures the multiple tokens together and creates a capture group for extracting a substring. So that's how we're building a substring here. And then you can click on the next one, and it's saying that's a character set in the range A to D. And then here you can see it's highlighting that it's a qualifier, so there has to be 3 characters in that qualifier. And then we've got another range. So this is a really nice tool, I think, for figuring out what a regular expression is doing. So if you search the internet and find a regular expression that somebody else has written to solve one of your problems that you think you might solve, you can paste it into here with a bit of the text that you want to test out, and it will kind of help you figure out what that regular expression is actually doing. So that's one of the many, many different regex tools that's available to us. And in that site, it does talk about the capture group and the numeric reference. And so that's we're going to see that in a moment. But so the numeric reference, flicking back to my lab here. So I've got a capture group here, the green. So this is the substring I might be interested in. And that first capture group gets a number 1, and in regular expressions you can reference that in FME land with \1. So that would be the first capture group. Okay, so let's do a little example. Let's bring up example 1C, regular expressions, FMW. Have a look at that. We don't have too much on our Knowledge Center yet around regular expressions. So we're just working through the slides here. So I'm going to drag up example 1C. Oh, sorry, I'm not going to do that first. No, I've got a little on-the-fly example that I want you to do. So you can just open Workspace and start with a blank workspace. And so here's the experiment I want you to do. So we're going to just work through this together very slowly. So we can just trying to get to the main again. Lab's a little slow. Okay, so let's drop down. So open a blank workspace. And we're just going to create a little test here. So we're going to add a creator transformer just to start things off. We could work with some of the sample data we've got. And then I'm just going to add a attribute creator. Okay. And in there, we're just going to create a temporary attribute. Let's just call it test attribute or something. And that will have a similar pattern to the one that we've been looking at. So we're going to put in A, B, D, and then 1, 2, 3, 4, 9, 8, 7, 6, or something like that. Okay, so now what I want you to do is just quickly, there I've got it still up here, even though that's not from the same, a similar piece of code here. So what I want you to do is just put down a third transformer here on this simple workspace, and I want you to build get a transformer to extract the first 3 characters of that code that we've just put in here. So we just want to extract and create a new attribute with the first 3 characters in that test attribute value. Just give you a couple of minutes to have a go. So you can choose whether you want to use it, try and use a regular expression. You can choose whether you want to use some of the string functions. So you could do that. Some of those you could do right here in the same attribute creator, or you could use some of the try and use a string transformer that might do that for you. Yeah, somebody's asking, can you view the presenter and the lab at the same time? I don't think you can, and but I'm just waiting here. I've just got the creator and the attribute creator sitting there. Thanks for pointing that out, Christine. I'll try and remember that when I'm flicking backwards and forwards. And Joanna says that if you can do it in an FME function, then it's probably going to be a little bit faster. That probably is true. Regular expressions are a little expensive in terms of performance if you've got to do lots of them. So if it's a simple problem you're trying to solve, maybe stick with string functions in FME. If it's more complex substring extraction, then maybe you have to revert to Regex. Okay, so if you feel like you want to share how you solve that problem, just type it in the public chat there. Just tell us what transformer or function you decided to use to solve that simple problem, extracting the first 3 characters of that code value. So first one up, substring extractor. Okay, so now now I'm going to go and open that transformer, sorry, that workspace, exercise 1C, regular expressions. And I should have done this in a few more of the exercises, but in this workspace, I've got the link there to the little webinar that we gave on this some time ago. So if you want to review some of these ideas, you can go back to that webinar. Okay, so if you want to follow along, I'm in, get into following the presenter for a little bit. Okay. All right, so this is the same problem, and so I've dropped down on this little workspace a whole bunch of different approaches you could take to solve this simple problem in FME. So I'm just going to run it. It's not pointing at the right folder, so let's try that again. Machines are a little slow today. Yep, somebody used the left function just to grab the first 3 characters on the left-hand side of that function. That's great as well. Thanks for sharing that. So we've had a couple of substring extractors and a left, and that's all that anybody wanted to share. Okay, so there's a few ways that we could solve this problem depending on what information you wanted out of this data. So if you just wanted to split that code into 2 different parts, if we wanted the characters and then the numeric at the end, one of the tools we could use is the attribute splitter. So the attribute splitter has 2 bits of options in it, essentially. One, which is the most common one that we use if we're probably using attribute splitter, is to use a delimiter to split the attributes. So you might have an attribute that's comma separated or pipe separated or something, and you want to split it. So normally we would use a delimiter, comma or pipe or tab or something. But it also allows you to put in a format string. So in this case that works pretty well. We know that the alpha code part of this value is just 3 characters, so we can say 3s, and then we might not know how long the numeric value is, but it wouldn't really matter. Even if we put in 20s here, it would just give us the characters that it found. And then we're creating a list here that we're going to talk about later on in the morning, and so it's created the list, and the output of that is, if we look at the, oops, look at one of those, there's the results there. List 0 and list 1 are the 2 parts of our string. So that's a equally good way of getting those first 3 characters. Then we could just rename that first list element. So that's one way we could solve this simple problem. We could, I'm going to jump down to the attribute manager here. We could revert to attribute manager and use some of the string functions. So some of you have already used that. We've got at left, which is the left function. Taking a while to wake up. There it is. It's not letting me widen that. So we've got the at left. We've got substring, using the substring there in the text editor. And if you feel up to the challenge, you could have used the regex function that's available in the function list of string functions. So that's all part of the string functions operations here in the text editor is the regex function. There it is. Okay, so that's a couple of options around using actual functions within an attribute manager. We could use the string searcher. So this is really, I would say, the primary transformer for building regex expressions in FME if you're going to work with slightly more complicated regular expressions. So it says contains a regex expression. We have got a regular expression editor in FME, so that really will help you start to build up your regular expressions. It's got a quick reference, so if you're not that familiar or don't use regular expressions that often, you can just check for simple things that you can put in here, and then you can type in your test string here, and that's a numeric match there, and it's going to give me tell me that it's made a match there of that string, and so we're going to be extracting those two values there. And then the string searcher has quite a few options. So under the advanced panel, there is the ability to say I want to create the list of the substrings that I've created here. So I'm in this particular regex, I'm extracting two substrings, the alpha value and the numeric value, and splitting those out. So that's very similar to what we were doing with the attribute splitter there. And we should see the results of that here. And so there's our first match, which is the actual string that we matched. And then below that is the substring part 1 and substring part 2, or part 0 and 1, depending on how you like to count. It also gives you the indices of on that string of where those parts started, so you can use those. So the string searcher, really powerful tool if you're really going to start working with strings as well. And well, the same problem here, just down here. The string searcher actually is a testing tool as well, so it will tell you whether that pattern matched or didn't match, and so that's a really good way of sorting out whether regular string patterns are, or a substring in a string matches something that you need, and so you can validate it. And then I've just got the string replacer in here because that's useful, because it does show how to use the numeric reference. And so if I want to take the code and just keep the first alpha values, again, I can use the text to replace, which is a regular expression, so that's there. And I know it's hard to see my screen because I'm going to change the resolution in a minute. But this is the substring that I'm trying to select in the window here. Here we go. Within the brackets there. And I think I've got that in the annotation. Yeah, so the blue in the annotation is inside that capture group. And then instead of actually having some replacement text, I can just put in the number of that capture group. So I'm capturing the first part of that string, my A to Z characters, and then I'm replacing the current string with that capture group, which essentially just gives me the ABD first three characters. So that numeric reference is very useful for string replacing as well, where you can extract a substring and just get rid of the other stuff around it, if that's what you want to do. All right, so our next little session here for the morning is yeah, it looks like some people, the screen is a little fuzzy, but hopefully the text size is bigger, so it is better. What happened there is when we were testing out the Strigo, I had an older monitor that I have at home, and then Safe Software have given us brand spanking new work at home monitors, and so we hadn't quite tested this new high resolution monitor out on you on the Strigo. All right, so date time operations. Let's leave regular expressions behind us for now, although they can be useful in date time kind of problems. You can see a very free-form date time down here, so you might want to use a regular expression to extract what day of the week it is. So you could practice that and or extract the month in letters there, and anybody that solves that problem before we go home can get the privilege of wiping the blackboard. Okay, so Christine asked us, can we just recap on using the /1 for the numeric reference? Sure, we can, Christine. Okay, so in a substring, I'm going to head back to my lab. So the numeric reference is \1. And I'm going to go back to my lab here. Hopefully this can see this a little bit more clearly. Wake up. While that's waking up, maybe I can explain it here in the looks like my lab has decided to go to sleep on us. Oh, okay, restarting. There we go. But actually, I'm going to go back here to this expression here. This is the same expression. And so the numeric reference \1 is related to what we call the capture group. So a capture group is regular parentheses that capture a part of the regular expression, and that will give us a substring. And you can have multiple capture groups. So if we wanted to split this string into two parts, the alpha and the numeric part, I could add in here another set of brackets if it's going to let me type. Oh, it's all behaving a bit slowly. But anyway, I could, oh, there we go. I could add a second capture group there. So later on in my regular expression, or in the case of the string replacer, I can reference that capture group or the results of that capture group using the /1 or /2. So in this case, I've got two capture groups. The first one, which will be my first 3 characters, which is the alpha part of my test string. And the second capture group is the numeric part of my test string. Doesn't show up here, but down here you can see that described. And if I want to reference the results of that first capture group, then I can use the numeric reference \1, and that will dig it out for me. And that's what we're doing back in the workspace, is I'm getting that first capture group, which is the ABC 3 alpha characters, and then I'm just saying, okay, once I found that, I just want to replace the whole string with that code and get rid of the numeric values. So hopefully that helps in the string replacer. So it's kind of a search and replace thing. Okay. And to be honest with you, I always forget about it. It's a very, very useful little thing. We should actually put it up in our quick reference. Don't forget the numeric reference and capture groups, because it is pretty useful. Okay, back to date times. So date time operations. Well, first off, dates and times are more complicated than you would normally think. You know, we can read them as humans very easily. They come in many different shapes and sizes, and we've also got time zones in there that complicate the whole thing. But the key thing to remember is that most formats that we work with have date-time structures that are unique to them, and they often have an internal structure as well as a display structure. Excel is the worst for this. So Excel underneath, if you open up an XLS file, unzip it, have a look at the XML documents that lie underneath, you'll see that dates are stored like this if the field is listed as a date field. But you can choose whatever display format you want for Excel documents, and so that's usually related to the system date that you've set for the system date format in your Windows machine. SQL databases have a pretty standard date format. That's this one here. There's ISO date format that FME server uses. That's this one here. And then of course you've got freeform date formats, which can be almost anything that you want. So how do we translate from, say, SQL to Excel via FME? So if the data that you're working with has a date time data type, and FME recognizes that, so most databases do have various date time data types. Excel has a date data type. When we convert that data, what we have to do is we're reading from the Excel, their underlying date format here, and then, oh, sorry, the other way around. We're reading, in this example, we're reading from SQL, this date format here, and then we want to create this date format for Excel. And the way FME does that is it goes via the FME internal date format, which is a very simple one. It's this one here. So year, 2-digit month, 2-digit day, hours, minutes, and seconds, could be decimal seconds optionally as well. So FME works with its internal date format. And if you're reading data from a format that has a recognized date time data type, then FME will read it and convert it into the FME datetime field. So that is confusing for things like Excel or possibly SQL Server, where they have the internal format and a display format, because typically when you look at Excel documents, you have the dates displayed in some way, and then you see it in FME Data Inspector and you're getting a date that looks completely different. And so that's not something you need to worry about. That's FME doing its job, converting the date time to its internal format, ready to convert it back to whatever the target data structure needs to be at the other end. There is an article, I think, yes, Ryan has just chatted it out, thanks Ryan, that kind of describes some of those ideas in there, okay? Again, date time operations in FME are available as both transformers and as functions, and so you can access those date time operations within the text editor in places like Attribute Manager, Attribute Creator, or if you prefer to sort of use them as sort of objects on your canvas so that they're a little bit easier to see where you're doing the date manipulations, they are available as transformers. And so that's probably the most common place that you can use those, that people will use those examples. All right, so we're going to start off with a little example here. What we're going to do is open up example 2A in a workspace. So I'm just going to hop over to my lab to get that kicked off, get rid of that one, and open up example 2A in your workspaces. Okay, and the exercise is at the top there in the annotation. And so what I'd like you to do is run this workspace, check the results, and you'll find that all the dates are all the features are being rejected in the date-time converter. And so what I want you to do is see if you can create the text string for the date-time converter, the input format that will match that date time that's coming in. And a little tip here that we often forget about on the date time function, so I'm going to show it to you just to give you a head start if my virtual machine will wake up, is there's a quick reference. So that's, you can go to the help as well, but there's a quick reference there at the bottom of the date time converter. And there is also a preview window. So if you enter the input string that you're trying to input date that you're trying to convert, then as you enter the input format, FME will possibly help you a little bit to show you what the result of that conversion that you're doing. Okay, I'll give you a couple of minutes to do that. Okay, if you want to follow along again, hopefully you had some success there. Ryan's giving you the cheat sheet answer there, that's good. So that's the string that it should look like there. The only tricky part there is the month. Usually we're used to working with a 2-digit month, which would be % lowercase m. In this case, we've got a 3-letter English month name, and that is %b. You can see there are lots of options here on setting the date time things, and there's also a few wildcards that you can use in there as well. And so it uses the % to get the symbol for the particular year, month, day, hours, minutes, seconds, and so on. And then you can put in any other characters, the dashes, the semicolons, spaces, whatever you need. Okay, so hopefully most of you had some success getting that simple date-time string conversion done. So that's an example where CSV, which of course doesn't really have any particular data types, didn't have an interpretation of the date time, and so we had to do that conversion before we write it out. In this case, writing out to GeoPackage, which is based on SQLite, and GeoPackage does have, if we'll get the user attributes come up, a date time data type. And so once we've converted the date time into FME's format, then FME will automatically convert it into whatever SQLite sees as a date time attribute, which is probably the SQL structure for date time. Okay. There's another little example there which we're going to skip. It's just date time calculation. So there's a transformer date time calculator for getting the difference between two dates. I think that's simple enough. So in the interest of time, I think we're going to skip over that one. If you want to have a look at it a little later on, when you grab these workspaces, then we can do that. You can do that in your own time. Okay, so big chunk of the morning, the rest of the morning we're going to spend talking about lists. I think we're going to possibly overrun just a little bit in our time. Sorry about that, but lists are very important part of working in FME, so we're going to stick to that through to the bitter end. So that Ryan is posting out there a couple of the articles that we can work with in list attributes, and they're all up there. There's 3 of them. There's kind of an introduction to working with lists. There's an article creating lists with transformers that we're going to work with here, and then there's the working with lists, which is using lists that we'll use to wrap up the day with. So I'll pop that up in a minute. Okay, so we've got a few resources that are great knowledge center articles that you can access there. So what are list attributes? Well, lists are attributes that have more than one value, essentially, and lots of other programming languages, particularly Python, have representations of lists. So if we look at the parks in Vancouver, China Creek North Park, it's got a bunch of trees in them, and so we might want to have some representation of what different trees we have in each park in Vancouver. And so how would we represent that? Well, we could have one feature for each park, so we'd have the park name and then the tree name. So that would be 3 features in this case. Got 3 trees in that park. Or 3 tree species. We might have more than one tree of the same species. So that would be a lot of duplication of data. So the other approach, which is common, you see, is having just a comma separated list attributes. So that's that first example there. We could just have a single attribute trees, and then have a list of the trees in that park. So that would be a single record representing the park, but be hard to work with if we were looking for parks with cherry trees or hawthorn trees or whatever. That kind of list structure, comma separated list, is a little harder to work with. So this would be a good example of using a list attribute. And so list attribute in FME is made up of list elements. It's just got the squiggly brackets around it. So we've got 3 list elements in the simple list example here. So we've got trees, ash, cherry, hawthorn. And so that trees list represents multiple values of the trees attribute. And then we can have slightly more complex lists on the right-hand side there. So we might have more information about the trees, like the genus and the common name. So typically these attributes, these list attributes, can take many different forms. But in this case, we might have trees, squiggle, 0, dot. The dot doesn't really mean anything, but it's just handy. And then we've got the actual attribute name, as it were. So we've got the common name, which is ash, and then we've got trees, squiggle, 0, the genus, and that's the sorbus genus for an ash tree. And so we've got more information for that single park stored in that list there. Hopefully most of you have encountered list attributes a little bit. I mean, it's hard to avoid them in FME because they kind of pop up in different places. Okay, so we're going to look at the article, and I've got to try and figure out how to do that here in Strigo. We're going to look at the creating lists using transformers article. So many transformers in FME do create lists, and we're going to work through that with the point on area overlayer transformer. And Ryan has just popped up the link to the article there, so I'm going to go to my lab, and close that. Open up a web page and bring up that article. Sorry, can't trying to get that article up here on my screen, and I'm not that familiar with we'll just do the good old search, yeah, in our articles. Oops. It's a little delay on my machine, so it's just okay, there we go. Okay, here we go. And so what we're going to do is we're just going to work through this article here. I've downloaded the, if I can scroll down here a little bit. Oops. Oops. Oh, right. It's time to wake up. So we're going to open up the workspace. We're going to use the point on the area overlayer transformer to do some overlays of the trees on parks, and then work through how that will look in the workbench and the results. So what we'll do to start off there is open up Workbench, and then you can open up the example 3 begin, drag that into your workspace. So somebody's asking, how can I export a list to a table? We'll have a look at that a little later. So I think I will answer that for you when we get to the section on working with lists. So this is the little example here. Hopefully you've got the article up and ready to work with. And what we're going to do is run the workspace just to have a look at the source data. So what we're doing is we're getting the postal address, joining that to the trees database just to give us a location for the trees in the parks. And you should be able to see those points and parks overlaid there. Then you can disable that those inspectors, and then you're going to start working with the point on area overlayer to do the overlay and look at the results there. So that's all in that article here. step one, run the workspace and go ahead. Okay, so it all comes from Mark suggesting that they don't want the output of ports they don't use. So that is true. Actually, it's only when you're in feature caching that the data from ports is put out. So if I disable this port, which I'm going to do because I don't really need it anyway, if you're running a workspace in production and that there is no connection there, that data isn't produced. It's only in feature caching that we create the additional data. So that is, will slow down the workspace when you're using feature caching, but should be okay. Most output ports, if they're not connected, nothing, it's not working there. Okay, so we ran through that article. Hopefully that was okay. And we looked at the point on area over layer, and it's hopefully creating some lists for you. So let's have a look at what that looks like. And I'll just run this guy a couple of times. So let's toggle off the list generation. So most transformers have the attribute accumulation. Transformers that do kind of joining operations like the overlayer series, they will also create lists optionally. So in this case here, if we just run it without any of those things checked, it'll tell us that there's overlaps, and if we look at the areas, and typically you have to look at the feature information window to see the lists that have been created. Where's my feature information window gone? Yep, there it is. And I've increased my screen resolution, so not so much screen space here. If I don't use the machine for the lab for a couple of minutes, then it seems to go to sleep. And you should see it's got the number of overlaps, but not too much going from the points that came in. So if we use the option here, merge attributes, what's going to happen is basically only the first feature that came through, we're going to see the attributes from that one. So if we had 3 trees in the park, we'll just see the first tree that happened to overlay with that park, and so that's not particularly useful in most cases. So that's why we want to use the lists. Going back there, and I'm going to uncheck this here. If it'll let me, there we go. And again, the point on area overlayer, and most of the transformers that have dual output ports will allow you to choose which particular port you want to add the lists to, and then you put in the list that you want to work with. Oh, this guy is slow. Okay, I'm not going to worry about the spelling too much there, it's so slow. And then you can choose which attributes you want to add to the list. So actually this is relatively new in FME, so if you've been using an older version of FME, at a guess pre-2018, but might be a little earlier than that, in the past all you had is the option to put the list name, and then every attribute that was on the incoming feature that you're sort of overlaying would be added to the list. Now lists do take up memory, so we've added this idea of, rather than having all attributes joined on the list, allowing you to be a little bit more selective and choose which of the list elements you want to work with, so that you don't have redundant list elements floating around, and you only keep the ones that you need to work with in your workspace. So that's a really handy feature that was added a little while ago. And if we run that, select one of those. And we should see our list there. So okay, well, I'm not seeing it, but I think that's just because this machine is kind of rumbling along a little slowly for me. Okay, so that's creating lists. Now there are many transformers that create lists in FME. Most of them are ones that join features together. So often they've got two input ports. Usually they will have a group by, because a group by is a kind of a way of joining clusters of features that have common characteristics or common ID. They will generally have a generate list option on here with an option to put the list name and then the other attribute accumulation parameters. And so examples of those are feature merger. So I'm sure you've encountered some of these before in your FME work. So let's bring up a couple of these as examples quickly. You don't need to connect them up, but the feature merger has an option. If you've got duplicate features, then you can generate the list, and then it'll give you the same parameters that we saw before, and that's a way of getting a one-to-many relationship from the feature merger. Feature joiner doesn't have this option, but feature joiner does support a one-to-many operation. So if anybody wants to make a guess at why the cousin of feature merger, feature joiner, doesn't need a list attribute accumulation, they can post it in the chat there. And another one that actually got recently got list treatment, if you are working with topology a lot, is the topology. It's so slow that I don't know what I'm typing here. Is the topology builder. And so in the past, the topology builder, actually until fairly recently, if you wanted to merge together, get lists of features, list accumulation, it was kind of complicated. So we now have options here to generate lists of edges, the nodes on edges, edges on nodes, nodes and edges on faces. So fairly complicated lists can pop out of the topology builder. So that's another way of doing point on line kind of operations in FME. Okay. Any questions around that, creating lists? Hopefully you can get familiar with those, and remember, keep your lists nice and trim. Don't put too many attributes on there, because they do accumulate and they do consume memory. And it's very easy if you're in a workflow that has where you are using lists in different ways, then it's easy to get features with multiple lists floating around when you don't really need them. Okay, so relatively easy in FME to build lists, and of course we already saw that earlier on when we're using the attribute splitter. That was one place we created lists right there with the attributes that we split. We also saw lists in the string searcher where we could get a list of the substrings if we had multiple substring lookups. So that's different place that we can get lists. So let's have a look, and we're going to probably go about 15 or 20 minutes over time, I'm afraid. Let's have a look at how we can work with lists. And so we're just going to work through these, just walk through these transformers. Maybe Sam or Ryan can post the link to the article in the chat there, transformers for working with list attributes. And so let's just do that. And Sam is asking if these machines are going to shut down on the dot at 10 o'clock, so I don't know the answer to that. So hopefully not. Okay, so let's go to my lab quickly, and I'm just going to open up a couple of the examples that we've got and just walk through the different examples. Ryan has extended the time, so we're all good. So I'm going to get rid of this example here. And what we're going to do is open example for a list exploder. So we're going to be looking now at the different transformers that we have for working with lists. Pretty well going through, looking at our workspace statistics, going through the list transformers we use that are most commonly used in FME from the workspace statistics that we get. Okay, so this is an example of reading some data similar to our cell signal data and doing an attribute validation on that. And so the attribute validator is a great tool for checking your attributes. You can use regular expressions, different types of expressions, or validation rules. So transformer, very worth becoming familiar with. And so if a feature fails, then it'll get put out the failed port. But what happens if our feature fails more than one test? What happens then is that FME creates a list of the problems. So let's have a look at the results there. And I think if I scroll across to the right, I can see which one has multiple values, maybe not. Okay, let's see if I can get this feature information window to show. I can't see why it is not popping up. Oh, there it is. So we've only got one error in this particular feature, but here we can see we get a validation message that's a list, and it tells you what's wrong with your feature. And so somebody earlier on was asking what happens if I want to create a report in Excel and I've got multiple list elements. And so this is where you have to split up the list into separate records. Excel doesn't have a list structure, as far as I know. And so what you need to do in many cases, and so this is one of the most common of the list handling transformers, is you need to take the list and split it into separate records. And so in this case here, we've got 13 features that came out, and when we explode that list, so what that means is it means that I take the individual list elements and create those as separate attributes and create a new feature for each individual list elements. And the list exploder has a whole bunch of different options about how you want to handle the attributes that are on the feature and the results of the list. So that's part of the attribute accumulation part of this transformer. So the option here is merge the list attributes. So each element of the list gets added as a new attribute on the feature. And then if there's a conflict between the name of an attribute that's in a list and an existing attribute on the feature, sort of a normal attribute, let's call it that, then we can choose what happens there. Do we keep the list value or do we keep the original value? And so what does that look like when we get those separate features? We would end up with an attribute there. Instead of as a list, it'll be a field, which is in this case the FME validation message as separate records. So those features that failed multiple tests get a list of more than one list element, 1, 2, or 3 list elements, and they get split out. In this case, we get 19 features instead of the 13, and each of those list elements now is attached to the feature as a regular attribute. And in this case here, I'm using the attribute manager to rename that and then writing that out to an Excel validation report. So hopefully that answers the question around that. Okay, so next up, I'm going to look at the list builder. So actually, this isn't really a transformer that manipulates list. It builds list, as its name suggests, and so it works in a similar way to the point on area overlayer or many of the other transformers that create lists, but it's a really good one. Uncommon one. So it's basically a joiner type of transformer. I'm going to drag that up here. If you want to follow along, we can just drag the list builder onto your canvas. And I'm going to run it. So again, I've got a CSV file that's got a list of parks and tree species, and I want to have all those trees accumulated onto the same park. And so I can use the list builder. The group by is a kind of a key here. So I'm grouping by the genus, and so it's going to, sorry, the other way around. So it's going to tell me for each tree genus which parks that tree sits in. And so if we click on the results of that so for example, if we have to do some investigation on diseased maple trees, we would know which parks we would have to go and visit. And again, this sad thing is so painfully slow, I'm not sure whether it's worth looking at the results. Here we go. And so here we go, we've got the genus list, and it's got the common name and the park name there. So we would see a list, in this case only one tree in that particular park, and we can work with that. So there's a couple of other good transformer list manipulation transformers here. So say we just want to find the parks that have a maple tree in them, then we don't need to know if there's multiple maple trees. We don't really need to know that. So transformer, the list duplicate remover. Again, we could just thin the list down so that only a new list is created that only has the that particular park in it. So duplicate parks are removed, and then the list concatenator actually will take a list and create a comma separated attribute, so we could just get a simple attribute that represented all the parks where a particular tree species sat. So that's an example of a few of the list manipulation, a couple of the list manipulation transformers. But the key one here is the list builder. It's another way of specifically creating lists. So it really just works with the attributes on your transformer, unlike the point on area overlayer where we were also kind of manipulating the geometries. Okay, and then just to kind of finish this little part is I've got a workspace here that we'll just walk through again. If this machine will wake up for me. There we go. And it's example 4C, the list trees complete example. And so this is the same problem that you were working on earlier on, the point on area overlayer. And then it's got a whole bunch of examples here of what you could do with the results from that point on area overlay. I'm just going to run it and then hopefully we can look at the results. And I picked out in green here, I think list manipulation transformers that you will probably most likely come across. There's a whole bunch of fairly unusual ones that aren't used as much, like the list histogrammer, but these are the more common ones. So we've got our point on area overlayer doing our, we've got our park areas with our list of trees that you were working with just now. And so there are sadly only 14 parks with trees in and 78 with no trees in Vancouver. And so these are the kind of list manipulation transformers that you can work with. List element counter. So that just gives us a straight count of how many elements are in that list. So this is a way to get the count of trees in that park. So we did the overlay, got a list of the trees, how many trees were there. The list element counter will give you eventually a list of those trees, the tree count. And if we scrolled across the bottom, not letting me do that, then that's how you can get that list element count. There we are, the tree count, and should be able to sort that. So we could find the more interesting parks that have the most trees and so on. Okay. List sorter, I've been using that quite a lot recently, so I think that's a pretty useful transformer for manipulating lists. So that's if you wanted to find the biggest tree in the park or some other characteristic of your list that's a numeric or alphanumeric value, it's a way of picking off the largest or smallest value very easily. because what it will do, it'll sort the trees. So in this case, I'm sorting by diameter. And then if we sort in this case, descending order, you can see in the pop-up there, sorting by tree diameter in this descending order, then I know that the first element on my list is my largest tree. And so now you can just either use Attribute Manager or List Indexer in this case to select the first element, and the List Indexer converts, in this case, the first element, all the attributes in that first element into regular attributes. And so we now end up with a feature that's got the tree with the largest diameter for each park. So the list sorter is very useful for sort of organizing your lists, and then you can pick out key parts of the list. Clean up after your list. So don't forget that attribute remover removes regular attributes as well as list attributes. So once you've finished the manipulation you have to do on your list, get rid of it, because otherwise FME's feature is going to carry that all the way through your workflow, and it's going to consume memory resources that possibly you don't need to be consuming. So if you've got complicated workflows and you're creating lists, get rid of them as you use them and don't need them anymore. List Searcher, another great transformer. So if we wanted to do an inspection for parks that have oak trees, maybe we've got some oak disease or fungal disease attacking our oaks and we need to go to find the parks that have oak trees, we can use List Searcher and find that. Again, we can either do a regular search, do numeric searches, or use a regular expression. So I'm using a regular expression, does it because we don't know whether our oak trees are named upper or lower case or mixed case, title case. And so we can do a list search there, and if we find the oak tree, so this will give us the features that the parks that have oak trees in them. Again, coming back to that question of, well, how do we report this out? Because most of our formats that we work with don't support list structures. Probably XML and JSON are probably the two that come to mind that have kind of data hierarchies where lists list kind of structures can be written out. So if you want to create a report of parks and trees, now that we've merged the data together, again, the list exploder can be used to break up the lists into separate records, and then we can write that out to an Excel file. And I think that was it. There's a couple of other examples here of some of the lists that list manipulation transformers that are in FME. If you just type on the canvas list when you're searching for transformers, you're going to see them all pop up and you can scroll through them. And then on top of that, I'm going to come to that again in a little bit more later on, but we've had many users write additional list transformers that are available on the FME hub. So more sophisticated list manipulation that is not available in FME. Somebody has probably written a tool to do it on the FME hub. If it doesn't quite meet your needs, that's one of the uses of FME hub. It gives you examples that you can work from. Better to steal some work and modify it than go from scratch. So you can download these FME hub transformers. The list appender takes two lists and appends new elements to it. So lots of different tools on the FME hub. Okay, and so around that same topic, so if there is some complex manipulation that you want to do, and FME's tools don't really do it in a nice, succinct way, you can use the Python caller. TCL also supports list, but it's a little harder to work with. So if you sort of have a historic attraction to TCL like I used to, but I don't anymore, I used to write list manipulation tools in TCL. I'm not a strong Python developer myself, but I can steal somebody else's work and modify it. And so that's typically what I do. So Python has a really good internal representation of lists that are very similar to the way FME works with them. And so down in the bottom right panel there, you can see that. So Python representation of a list of trees is like that. FME's representation is like this. And within the Python, you can get your attributes with the feature get attribute function, and you can set an attribute with the feature set attribute function. And so you can bring a list into Python and it will give you the Python list structure. If you manipulate your list and you want to send a list back to FME, you can do that from using the set attribute function. So those are really great ways of making more advanced uses of lists. And whoops, go back to my lab. Got a little example of that here that you can sort of poke around. This isn't a lesson on Python. Definitely not going to attempt to teach you Python because first off, I don't know enough Python to be able to do that. But and we don't have time. But have a look at that. There is an FME for Python Basic course there that if you want to become familiar with Python in FME, you can. Just going to run this quickly and then say why we might want to do this. So this is an example of where we want to do a pruning exercise on maple trees, and we only need to prune trees that have a canopy of greater than 25 meters. So in this particular case, that's easy enough to do. What we can do is we can do a list search for maple trees, and then we can do a second search for the canopy diameter, and the output will eventually pop out, and we would have the list of parks with big maple trees, and there we know where to go. But you can see how this would quickly kind of expand into a more complicated workspace with lots of list searches if we wanted to do that for oak trees and different diameters and so on. So Python would be a really good place to do this. So we can get our tree lists of using get attribute of the tree common name, the tree diameter. We can use all the Python functionality that is available to you for working with Python lists. We can also use regular expressions in the Python if that's something you're fallen in love with as part of this training. And then once we've built that new list of maple trees, in this case, we can use the set attribute and push that new list back out to FME and get the result that we need. So we can do quite very complicated list manipulation tasks within the Python and get the results out. And don't forget to clean up with the attribute remover afterwards. So you can see that even though there's only 2 list searches here for just a simple maple tree single diameter, you can see that that would grow quite a bit if we wanted to process other trees. And so that might be a good time to have a look at Python to see if it's worth manipulating the lists there. And another example of that where that would be kind of useful is if you do any kind of network or topology kind of work. So this is an example here where we've used a point-on-line overlayer or a topology builder to find the interaction of points, in this case a transformer, and the lines that connect to that transformer. And you might build a Python script that does validation here. So the question might be, you know, is a transformer is only valid if it has at least one medium line coming in and at least one low voltage line going out. And so we could write a little Python script, and this is the results of one that we have, that looks at the list of lines that are attached to that transformer and tells us how many low voltage lines and how many medium voltage lines, and gives us a list of those. And so then we could say this transformer is valid or not. And there's many examples of sort of topology problems, similar topology problems, where that is useful. Water or gas networks have mains and lateral lines or service lines, and so those often have to have a node at a junction at the junction of the service line and the mains, and you could validate that junction that has at least two main lines and a service line. Then you could say, well, we need to ensure that we have a T-junction or something at that location. So all sorts of things you can do in topology work with lists, and where Python caller and list manipulation might help you solve those kind of problems. Yes, and Joanna Hobbins, who's done lots of work in FME, has got a great webinar that she presented at one of our user conferences, which is online. So she's chatted out that. So thanks, Joanna. That's good. Good examples in there of why you might want to do more complex list manipulation. And as I mentioned, FME Hub, great resource. Sorry, that's a little bit blurry, but have a search there to see if there are tools that are close to what the problem you're trying to solve. Most of those are written in Python, and so that's a good way of learning how to use Python and lists together. And it's a starting point if the problem doesn't quite solve if the custom transformer doesn't quite solve what you want to achieve, at least you have a starting point to work with. So I think from there, it seems like we rushed through that latter section there, so I apologize for that. We are wrapping up, and hopefully you've learned a little bit more about working with attributes in FME and the different tools that we've got, from Regex, horrendous Regex, datetime, and working with lists. Ryan has pushed out the feedback form link there. So once you've filled out the feedback for the course, it will then point you to where you can do the quiz to make sure you're all paying attention, multiple guess quiz, and then Ryan will make sure you get a certificate of completion. So if you've got any questions, I don't mind sitting here for a little bit. Sorry I overran a bit. Otherwise, thanks very much for joining us, and hope to see you at one of our future training courses.